And now, in this lecture, we find out the area of the green shape. In the drawing, we have a semicircle, and we know that chord PC equals to 8 units in its length. The diameter BC equals to 10 units. This is angle ABC, that is right angle, and our task is to find out the area of this green shape. So first of all, we join points P and B together by straight line. By joining points P and B, create peripheral angle PBC. Peripheral angle PBC subtend on BC. It is the diameter of the semicircle, and therefore, according to Rule 5, the size of this peripheral angle must be equal to 90 degrees. This angle equals to 90 degrees in its size, according to Rule 5. So I can click on Rule 5. According to Rule 5, any peripheral angle that subtends on the diameter of the circle must equal to 90 degrees in its size. So in the drawing, we have a circle. AB is the diameter of this circle. This is peripheral angle AEB that subtends on the diameter AB of this circle, and therefore the size of this peripheral angle AEB is equal to 90 degrees. We have already implemented Rule 5 in our drawing. We have, this is peripheral angle BPC that subtends on BC, that is the diameter of the semicircle, and therefore the size of this peripheral angle BPC is 90 degrees, according to Rule 5. So, in the next step, we'll implement the Pythagoras theorem on the right triangle BPC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse of the right triangle BPC is BC, therefore the square of the hypotenuse is BC square. And BC square must be equal to BP square plus PC square. Here by PT is evaluation for Pythagoras theorem. Put again on the right triangle BPC for the Pythagoras theorem. BC square, that is the square of the hypotenuse, equals to BP square plus PC square. The hypotenuse BC equals to 10 units in its length, therefore BC square is 10 squared, it is 100. And it is equals to BP square. BP is the missing side, so we leave it as it is. BP square plus PC square. PC is 8, therefore PC square is 8 squared, that is 64. So in total we should find out that 100 equals to BP square plus 64. Here we subtract 64 from this equation. And we get that BP square is equal to 164 is 36. We take out of this equation and we get that BP equals to the square root of 36, that is 6. BP equals to 6 units in its length. In the next step, we define angle PAB, this angle as alpha. But before that, uh, if you focus on the left side of the straight line AC at point P, here the sum of the angles must be equal to 180 degrees according to rule 3, that says that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the left side of the straight line AC at point P? We have this angle, a right angle, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. So in the right angle APB, this angle equals to alpha, this angle equals to 90 degrees. Therefore, this first missing angle must be equal to 90 degrees minus alpha. Y equals 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. What is the size of this angle PBC? The size of this angle must be equal to alpha. Why? Because it is given us the question that angle ABC is a right angle, and this angle ABP is 90 degrees minus alpha. Therefore, this missing angle must be equal to alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees. That is the size of the big angle, angle ABC. Therefore, this missing angle must be equal to alpha. So in the right angle BPC, this angle equals to 90 degrees, this angle equals to alpha. Therefore, this third missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees it is equal to 180 degrees. That is the sum of the angles in any triangle. Actually, it is very easy to see that those two triangles are similar to each other according to angle similarity rule. That is to say, the triangle APB is similar to triangle BPC according to angle similarity rule. So, explain why those two triangles are similar to each other. First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha, therefore they are equal to each other. So if we found out that all the angles of the right angle APB are correspondingly equal to all the angles of this right angle BPC, and therefore those two right angles are similar to each other according to angle similarity rule. So I write it down. If we prove that the right angle ABP is similar this is the sign of similar to the right triangle BPC according to angle similarity rule. And for the fact that those two right angles are similar to each other, we derive that the following relationship exists between their sides. We derive that side AB of triangle ABP over side BC on the right triangle PBC is equal to side AP on the right triangle ABB over side PB of the right triangle PBC. PB is the common side that belongs to both triangles, and it is also equals to side PB of the right triangle APB over side PC of the right triangle APC. So if again we found out that from the fact that those two right triangles are similar to each other, the following relationship exists between their sides. That side AB of the right triangle APB over side BC of the right triangle BPC is equal to side AP of the right triangle APB over side PB of the right triangle PBC, and this also equals to side PB of the right triangle APB over side PC of the right triangle PBC. AB is the missing side, so leave it as it is, over BC. BC is 10, according to what is given in the question, and it is equal to AP. AP is the missing side, so we leave it as it is, over PB. PB is 6, and it is equal to PB, it is 6, over PC. PC is 8. So in total, we found out that AB over 10 equals to AP over 6 equals to 6 over 8. So those two expressions are equal to each other. Therefore, we get equation 1 from those two expressions that are equal to each other. So according to equation 1, AP over 6 equals to 6 eighths. Here we multiply the equation 1 by 6, and we get that AP equals to 6 times 6 is 36 over 8. Here we divide both the numerator and the numerator of this number by 4, and we get that 36 over 4 is 9, and 8 over 4 is 2. So in total, we found out that AP equals to 9 halves. AP equals to 9 halves. So writing down, AP equals to 9 halves. Those two expressions are also equal to each other. Therefore, we get equation 2 from those two expressions that are equal to each other. So according to equation 2, we get that AB over 10 equals to 6 eighths. It again, according to equation 2, I should find out that AB over 10 equals to 6 eighths. Here we multiply this equation by 10, and we get that AB equals to 10 times 6 is 60 over 8. So here we divide both the numerator and the numerator of this number by 4, and we get that 60 over 4 is 15, and 8 over 4 is 2. So in total, we found out that AB equals to 15 halves. This is side AB, this equals to 15 halves in its length. In the next step, we define the center of this semicircle. This point is point O, the diameter of this circle BC equals to 10. Therefore, the radius must be equal to half of it. That is to say, the radius must be equal to 10 over 2, that is 5. So, OC equals to 5. The diameter OB also equals to 5 units in its length. In the next step, we join points O and P together by a straight line. So what is the definition of line segment OP? It starts from point O, that is the center of the circle, and ends at point P, that is the point on the semicircle itself. Therefore, this is exactly the definition of a radius. Therefore, OP is the radius of this circle, the semicircle, that equals to 5 units in its length. We define angle POB. This angle is theta, and we implement the law of cosines in this triangle POB. According to the law of cosines, in triangle POB, cosine theta equals to 5 square plus 5 square minus 6 square over 2 times 5 times 5. And again, according to the law of cosines, in this triangle PBO, cosine theta equals to 5 square plus 5 square minus 6 square over 2 times 5 times 5. 5 square is 25, plus 5 square, that is 25, minus 6 square, that is 36, over 2 times 5 times 5. 5 times 5 is 25, and 25 times 2 is 50. Here we have 25 plus 25 is 50, and 50 minus 36 is 14 over 50. So in total, we found out that cosine theta equals to 14 over 50. Our task is to find out the value of theta itself. In order to find out the value of theta, we will perform the opposite operation of cosine, that is arc cosine on the result. In this way, we get the value of theta itself. So, arc cosine theta, that is the opposite function of cosine, is equal to, what is the value of arc cosine theta? First of all, cosine theta is 14 over 50. So arc cosine theta is the arc of 15 over 14 over 50. The arc of 15 over 50 is equal to 73.74 degrees. So if you found out that angle theta equals to 73.74 degrees. Okay. This is angle theta, and the size of angle theta is 73 73.74 degrees. Our task is to find out the area of this green shape. So first of all, in the first step, we calculate the size of segment BP. This is segment BP. So the size of segment BP from the drawing, it is very easy to see that the size of segment BP is equal to the size of sector BOP minus the area of triangle BPO. So if it again from the drawing, it is very easy to see that the size of segment BP is equal to the size of sector BOP minus the size of this triangle BOP. So what is a sector? A sector is a portion of a circle with two radii and the arc between them. The green shape AOB is a sector. It consists of the two radii of the circle, and the angle between the two radii is theta, and the arc between the two radii is the arc of sector AOB. So what is the area of this sector? The area of sector AOB is equal to the area of the circle, that is pi r squared, times theta over 360 degrees. Again, theta is the angle between the legs of the sector, or the angle between the two radii of the sector, divided by 360 degrees. Okay, so we use the new formula in order to find out the area of this sector, sector BOP. We know that BO equals to 5, that is to say the radius of the circle or semicircle is 5. So the area of this sector BOP will be equal to pi r squared times the angle between the legs of the sector, that is 73.74 over 360 degrees. So in total, the area of the sector, again, pi and r squared. R is 5, so it is, therefore r squared is 5 squared, that is 25 pi. So it is 25 pi times 73.74 over 360 degrees. 25 pi times 73.74 16.74 over 360 degrees. In total, it is equals to 16.088 square units. So actually, the area of sector BOP is equal to 16.088 square units in its size. What is the area of this triangle BPO? This triangle is an isosceles triangle because side BO equals to side PO. So we will go from the vertex O, we will go perpendicular on the base BP. So this angle equals to 90 degrees. And this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and BP. This point is point M. We know that the vertex, the perpendicular to the base in any isosceles triangle bisect the base. That is to say, PM equals to MB. BP in total is 6. BP equals to 6. So BP is being bisected by the perpendicular OM into two halves. Each half must be equal to 3. So in the right triangle PMO, this side equals to 3 units in its length. The hypotenuse is 5, so MO, according to the Pythagoras theorem, MO square must be equal to 5 square minus 3 square. 5 square is 25, minus 3 square is 9, so 25 minus 9 is 16. So OM square equals to 16. We take a root out of this equation and find we get that OM is equal to the square root of 16, that is 4. OM equals to 4, that is to say, the height of this triangle, the associated triangle BOP is equal to 4 units. And we know that the area of any triangle is equal to the base of the triangle times the height over 2. The base is BP, that is 6, minus the height, that is 4, divided by 2. 6 times 4 is 24, and 24 over 2 is 12. So in total, we should find out that the area of this associated triangle BPO is 12 square units. 16.088 minus 12 is equal to 4.088. So in total, we should find out that the area of segment BP is equal to 4.088 square units. Repeat again, the area of segment BP, that's actually segment BP, the area of segment BP is equal to 4.088 square units. Our test is to find out the area of this green shape. What is the area of the green shape? From the drawing, it is very easy to see that the area of the green shape, the area of this green shape is equal to the area of triangle APB the area of triangle APB minus the area of segment BP is equal to the area of the green shape. Actually, the area of the right triangle APB minus the area of this segment BP must be equal to the area of this green shape. So repeat again, I should find out that the area of this green shape is equal to the area of the right triangle ABP minus the area of segment BP. What is the area of this right triangle ABP? It is equal to the base times the height over 2. The base is 9 over 2 or 4.5. The height is 6, so it is 4.5 times 6 over 2. 6 over 2 is 3, and 3 times 4.5 is 13.5. So total, I should find out the area of this right triangle APB is equal to 13.5 square units minus the area of segment BP. We already found out that the area of this segment BP is equal to 4.088 square units. And 13.5, that is the area of this right triangle ABP minus the area of this segment BP, that is 4.088. In total, it is equal to 9.412 square units. So, check that I didn't do any mistake here. 13.5 minus 4.088 is equal to 9.412 square units. So if we found out that the area of the green shape, that is the area that we are looking for in this question, is equal to 9.412 square units. And that is the answer to the question. I'll repeat again. If we found out that the area of this green shape is equal to 9.412 square units. Okay, so in the next step, I will summarize the lecture. In this lecture, our task was to find out the area of this green shape. It is given us the question that the diameter, so in the drawing we have a semicircle. The diameter of this semicircle is equal to 10 units in its length. In addition, you know that this is called PC. It equals to 8 units in its length. This is angle ABC, that is right angle. Again, our task is to find out the area of this green shape. So, first of all, we join points B and P together by straight line. By joining points P and B, we create the right triangle BPC. This right triangle BPC, actually, this is the right triangle BPC is the peripheral angle. Actually, this is by joining points B and P together, we create the peripheral angle BPC. Peripheral angle BPC subtend on BP, that is the diameter of the circle, and according to rule 5, any peripheral angle that subsets on the diameter of the circle must be equal to 90 degrees in its size. Therefore, this peripheral angle BPC must be equal to 90 degrees in its size according to rule 5. Okay, so we know that AC is the straight line. According to what is given in the question, AC is the straight line. So if you focus on the left side of the straight line AC at point P, of the sum of the angles must be equal to 180 degrees according to rule 3 that says that the sum of the angles on one side of a straight line is equal to 180 degrees. So we check that we have at the left side of AC at point P, we have this angle that is the right angle, plus this missing angle, in total the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. So in the right angle APB, we define this angle, angle BAP as alpha. So this angle equals to alpha, this angle equals to 90 degrees, and therefore this first angle must be equal to 90 degrees minus alpha. 1 equals 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in a triangle. This angle PBC must be equal to alpha. Why? Because it is given as a question that angle ABC is the right angle. Therefore, this missing angle must be equal to alpha. Why? Because alpha plus 90 degrees minus alpha is 90 degrees. That is the size of the big angle, angle ABC. Therefore, this missing angle must be equal to 90 degrees minus alpha. So in the right angle BPC, this angle equals to 90 degrees. This angle equals to alpha. Therefore, this first missing angle must be equal to 90 degrees minus alpha. 1 equals 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in a triangle. So this first angle must be equal to 90 degrees minus alpha. It is very easy to see that the right angle APB is similar to the right angle BPC according to angle similarity rule. So why those two right angles are similar to each other? First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha, therefore they are equal to each other. So if we prove that all the angles of the right triangle ABP are correspondingly equal to all the angles of the right triangle PBC, and therefore those two right angles are similar to each other according to angle similarity rule. And from the fact that those two right angles are similar to each other, we derive that the following relationship exists between their sides. But before that, we have the right triangle BPC. Side PC equals to 8 units in its length, side BC equals to 10 units in its length. BC is the hypotenuse. So BC square minus PC square equals to PB square. BC square is 10 square, that is 100, minus PC square, that is 8 square, that is 64. So 100 minus 64 is 36. So PB square equals to 36. We take a root from this equation, PB square equals to 36. So PB must be equal to the square root of 36, that is 6. So PB is 6 units. So from the fact that those two right angles are similar to each other, we derive that the following relationship exists between their sides. We derive that side AB of the right triangle APB over side BC of the right triangle PBC is equal to side AP of the right triangle APB over side PB of the right triangle PBC, and it is also equal to side PB of the right triangle APB over side PC of the right triangle PCB. PB is a common side that belongs to both triangles. Okay, again, from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side AB of the right triangle APB over side BC of the right triangle PBC is equal to side AP of the right triangle APB over side PB of the right triangle PBC, and it is also equal to side PB of the right triangle APB over side PC of the right triangle PCB. AB is the missing side, so we leave this it is, over BC. BC is 10. AP is the missing side, so we leave this it is. PB is 6. And PC is 8. So in total, if you know that AB over 10 equals to AP over 6 equals to 6/8. Those two expressions are equal to each other, therefore we get the equation 1 from those two expressions that are equal to each other. So according to equation 1, AP over 6 equals to 6/8. AP over 6 equals to 6/8. Here we multiplied this equation by 6 and finally found out that AP equals to 6 times 6, that is 36/8. Here we divided both the numerator and the denominator of this number by 4. 36 over 4 is 9 and 8 over 4 is 2. So in total we found out that AP equals to 9 halves. AP equals to 9 halves. Those two expressions are also equal to each other, so we get the equation 2 from those two expressions that are equal to each other. So according to equation 2, AB over 10 equals to 6/8. According to equation 2, AB over 10 equals to 6/8. Here we multiply this equation by 10 and finally found out that AB equals to 10 times 6, that is 60 over 8. Here we divided both the numerator and the denominator of this number by 4 and found out actually that 6 over 4 is 15 and 8 over 4 is 2. So in total we found out that AB equals to 15 halves. This is side AB, that equals to 15 halves units in its length. Okay, so in the next step, we defined the center of this semicircle. This point is point O. The radius BC is equal to 10 units according to what is given in the question. Therefore, again, the diameter BC of this semicircle is equal to 10 units, and therefore the radius must be equal to half of it. That is to say, the radius must be equal to 10 over 2, that is 5. The radius OB is 5. OC is also the radius that is 5. We join points O and P together by straight line. OP is also the radius that is 5. We defined angle POB as theta, and we implemented the law of cosines on this triangle POB. According to the law of cosines, in this triangle POB, cosine theta equals to 5 square plus 5 square minus 6 square over 2 times 5 times 5. Again, according to the law of cosines, in this triangle POB, cosine theta equals to 5 square plus 5 square minus 6 square over 2 times 5 times 5. So cosine theta equals to 5 square is 25, plus 5 square is 25, minus 6 square, that is minus 36. 5 times 5 is 25, and 25 times 2 is 50, over 50. 25 plus 25 is 50, and 50 minus 46 is 14 over 50. So in total we found out that cosine theta equals to 14 over 50. Our mission is to find out the value of theta itself. In order to find out the value of theta, we'll operate the opposite function of cosine on the result, and in this way we get the value of theta. That is to say, arc cosine, that is the opposite function of cosine, we operate the opposite function on the result, that is 15 over 50. So arc cosine theta, and we know that cosine theta equals to 14 over 50. So it is arc 14 over 50, and the arc of 14 over 50 is 73.74 degrees. So So if you found out that angle theta is equals to 73.74 degrees in its size. So this is angle theta that is equals to 73.74 degrees in its size. Okay, so first of all, we have to find out the size of segment PB. This is segment PB. For the moment, it's very easy to see that the size of segment PB is equals to the size of sector POB minus the size of this triangle PBO. Okay, again. The size of segment BP is equal to the size of sector POB minus the size of this triangle PBO. It's very easy to see that this segment PB, the size of this segment PB is equals to the size of sector POB minus the size of this triangle PBO. So what is a sector? A sector is a part of a portion of a circle with two radii and the arc between them. Again, a sector is a portion of a circle. You can see here, ABO is a portion of this circle, and this sector AOB consists of two radii and the arc between the two radii. This is the angle between the two radii, that is the angle of this sector AOB. And the area of this sector AOB is equals to pi r squared, that is the area of the circle in total, times theta, that is the angle between the legs of the sector, over 360 degrees. So in total, the area of this sector AOB is equals to pi r squared times theta over 360 degrees. So we use the new formula in order to find out the area of this sector POB. So the area of this sector POB must be equal to pi r squared times the angle between the legs of the sector over 360 degrees. R, the radius of the semicircle is 5, and theta is equals to 73.74 degrees. So pi r squared is pi r squared, that is 25 pi, times 73.74 degrees over 360 degrees. So in total, the value of this expression, 25 pi times 73 times 25 pi times 73.74 over 360 degrees, the value of this expression in total is equals to 16.088 square units. So if you found out that the area of this sector POB is equal to 16.088 square units, minus the area of this triangle POB. This is triangle POB. This is an associated triangle. Why it is an associated triangle? Because OP equals to OB. So from the vertex O, we do perpendicular on the base BP. And we know that when you draw a perpendicular to the base, PB is the base of the associated triangle, the perpendicular to the base in any associated triangle bisect the base. First of all, this is a perpendicular, OM is a perpendicular, therefore this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. And according to the rule that I mentioned, that the perpendicular OM bisect side PB. PB is 6, therefore each half must be equal to 3. So the perpendicular OM bisect chord PB, so each half must be equal to 3 units. So in the right triangle PMO, according to the Pythagoras theorem, PO is the hypotenuse. 5 squared minus 3 squared must be equal to OM squared. 5 squared is 25, minus 3 squared, that is 9. 25 minus 9 is 16, so 16 equals to OM squared. 16 equals to OM squared. We took out all those equations and found out that OM is actually the height of this triangle POB is equal to the square root of 16, that is 4. So the height of triangle POB, the associated triangle POB is 4 units. And therefore the area of this triangle, the associated triangle POB must be equal to the base PB times the height 4 over 2. PB is 6, the height OM is 4 divided by 2. 6 times 4 is 24, and 24 over 2 is 12. So in total, the area of this associated triangle POB is 12 square units. And the area of the sector is 16.088 minus the area of this associated triangle, that is 12. 16.088 minus 12 is 4.088. That is the area of this segment BP. So in total, we have found out the area of segment BP is equal to 4.088 square units. Our task is to find out the area of this green shape. Actually, the area of this green shape from the domain, it is very easy to see that the area of this green shape must be equal to the area of triangle ABP, the right triangle ABP, minus the area of this segment BP. And again, the area of the green shape from the domain, it is very easy to see that the area of the green shape must be equal to the area of the right triangle APB minus the area of segment BP. The area of this right triangle is equal to the base times the height over 2. The base is 4.5, the height is 6 divided by 2. So it is 4.5 times 6 over 2. 6 over 2 is 3, and 3 times 4.5 is 13.5 square units. The area of this right triangle APB is 13.5 square units. Minus the area of this segment BP. We have already found out that the area of this segment BP is equal to 4.088 square units. So for the area of this again, that is 14.5 minus the area of this segment, that is 4.088, in total it is equal to 9.412 square units. So in total we have found out that the area of this green shape is equal to 9.412 square units. And that is the answer to the question. Okay? Thank you very much.